What up, everybody? InstructaBeats back again here with our statistics unit. Today we're going to be asking the question, what measure of central tendency should I use? So we're going to be building on our last lesson where we introduced mean, median, and mode. And today we're going to be talking about different scenarios in which we should use them. Let's check out the data and look at our objective today. Our objective today, I will be able to recognize when mean, median, or mode should be used when measuring central tendency. But first we're going to start with our math vocabulary. So we've talked about range, we've talked about mean, we've talked about mode, we've talked about median, and we mentioned this word. We want to get it down in our notes, which by the way there is a link in the description to this video, and that is an outlier. An outlier is a data value that is way different from the rest of the data. You might be collecting data on how many stuffed animals your class has, and most people have around 4 or 5, and all of a sudden one person has 21, right? We would call that an outlier. It's way different from the rest of the data, and this is going to be important especially as we're looking at means. So let's review the 3 different ways we can measure central tendency. We have mean, median, and mode, right? And if you remember, mean is the average of your data set. The median is the middle number when the numbers are listed from least to greatest, right? So remember, you cross out the least and then the greatest, and you keep alternating until you cross them all out until you come down to either 1 or 2, and that would be your median. And then here you have the mode, which is the number that occurs the most in the set of data, right? And we've talked about that last lesson. If you need to take a break from this and go back and check out our last one, please do that. So now we want to add to our notes the best scenario in which to use these. So if you're trying to find the central value of a set of data, right? You want to find that center of all the data you collected. You're going to use the mean mostly when there are no outliers, okay? And we're going to show you why in a second, but if there are no outliers in your data, you can use the mean to give you a pretty good representation of the center of your data. You're going to use your median if there are outliers that skew the data. Okay, and we'll show you an example of this, but go ahead and get it down in your notes. And then you want to use your mode. Typically, this is the least used one, and typically you're going to use your mode if you're just doing categorical data. So this is going to be the one we use the least when we're trying to find out that center of our data. Typically, we're going to use mean or median. So here's a conceptual problem to kind of show you what we're talking about when we're trying to decide between mean, median, and mode. So the question we collected data for was the ages of your 10 closest friends, right? So you have a 12-year-old friend, a 13-year-old friend. You have three 14-year-old friends. You have 2 friends that are 15 years old, and then you have one that's 32, right? Maybe it's your mom. Your mom's your best friend, all right? And if you notice, there is a natural tendency around the center of the data. So let's take a look at this using a dot plot. So a dot plot is a lot like a line plot, and basically you're going to put a dot for each number to represent that. So we have a 12-year-old, 3 13-year-olds, so we're going to put 3 dots above the 13. We have 3 14-year-olds, we have 2 15-year-olds, and then all the way over here we had a 32-year-old. We would consider the 32-year-old to be our outlier, because it's way different than the rest of our data. So let's find the mean, median, mode, and then decide which of those would be the best way to represent the center of our data. We actually have a bimodal set of data here because 13 and 14 are both seen 3 times, right? So they're both going to be our modes. So we have 13 and 14, and again, that means that this is going to be a bimodal set of data. Our median, if we cross them out, so if I cross out 12 and then 32, if you notice these are already ordered from least to greatest. So if I keep crossing these out one by one, I get 2 14s, okay? When you're left with 2, you want to average them. Now, obviously, the average of 2 14s would be 14, but I just want to show you the math anyway. So again, when you're finding the median, if you have 2 numbers left, you add them together, and you find the average of those. So 28 divided by 2 would be 14. So my median is going to be 14. And then for the mean, you want to find the average of all the numbers. And when you add them all up, you're going to get 155. You divide that by your 10 parts of that. And the mean, or the average of all of them, is going to be 15.5. So you could say the average of your friend's age is 15 and a half years. Okay, the median was 14 and the mode was 13 and 14. Now, if you're really trying to find the true center of your data, what would be the best way to do it? Well, this is not categorical, so we're not going to use the mode. Okay, so the mode is out. So we need to decide between the mean and the median. Now, if you go back to your tree map we just made in your notes, you'll see that you use the mean when there isn't an outlier. If there is an outlier, like we have right here with 32, you would want to use the median. And let me show you why. So right now our average was 15.5, right? Well, the mean takes into account all the numbers. So if you change 32, for instance, let's make it 60, right? So let's say your best friend is 60 years old, which would be really weird, but that's okay. So let's change this number in our set to 60 and see how it affects our mean and our median. If we change our outlier to 60, that now makes our mean 18.3, which means they're telling you that the center of your data is all the way over here. All right. Well, you can see very clearly that's not true, because then 9 of your friends are to the left and 1 of your friends is to the right. That doesn't make any sense. That can't be a true representation. And again, that's because the mean is influenced by all the numbers. If we left your best friend as 60, or one of your best friends as 60, your median still doesn't change, because we're just crossing those numbers out anyway, and you're still left with 2 14s. So because there's an outlier here, right, we're not going to say that your average age of your friends is 18.3 years old, right? If you're a 13-year-old, you don't want the average of your friends to be 18 years old. That'd be kind of weird, right? You want it to be around your age. So the best center of this data is going to be 14. Again, that's because there's an outlier, and the outlier can affect the mean, but it doesn't affect the median. Let's take a look at an I do problem. So here our I do problem says, Juanita runs a 100-meter dash for her college. She collected data for 10 different races, and they're measured in seconds, so all these are actually seconds, throughout the season. We want to find the mean, median, and mode, and then the question says, what time can her coach expect her to run in the last race of the season? In other words, what's going to be a typical race for Juanita to run? So we're going to use our measures of central tendency to help us figure this out. So the first thing we want to do is we want to find the mean, okay? And to do that, we want to list all of these from least to greatest. So here I have her races listed from least to greatest, so from fastest to slowest. So you can see she runs a lot of 11s, kind of has a change in the tenths of the seconds, quite a bit in the 12s, one in the 13s, and then here we have an outlier of 21. So it took her 21 seconds to run the race. So maybe she tripped and then she finished. Maybe she hurt herself and she couldn't run as fast as normal, but we have an outlier right here. Okay, so let's find out what's the mean, what's the average time of all her races. So the average of all her races, again including the outlier, is 13 seconds and then 5/100ths of a second. The median we're going to get by crossing out. Before we do that, let's do the mode. You can see right here, and this is one of the reasons we don't use the mode a lot when there's the data you collected as numbers, because if you're actually timing something, if you're collecting data, a lot of times you're not even going to have a mode, right? There's no repeating values here. So really we don't even have a mode for this one. So we're going to cross this out. So our median now, if we cross them out one at a time, oops, man, I got to work on my crossing out. There we go. And I take turns, and let's see, there we go. My pen seems to be messing up. I think my hand's getting sweaty. So I'm going to have 2 left. So when you have 2 left, you want to find the average of them. So we're going to add them together, which is going to be 24 and 5/10. And then you want to divide that by 2. And you're going to find your median to be 12 seconds. Oop, there we go. And 25/100ths. All right. And so now we have our mean, we have our median, we have our mode. We need to answer the question. It says, what time can her coach expect her to run in the last race of the season? All right. So we're trying to find kind of that center value that she typically would run. If you look back at our tree map, again, we have an outlier here, which means we don't want to use our mean. And here's why. We have to include that one really, really bad race where maybe she tripped or hurt herself into our average, and that bumped our average way up. Matter of fact, if you take this outlier out, it would drop the mean of our data, or the average of all her races, all the way down to 12 and 15/100ths of a second. Now that might not seem a lot, but in track and field world, that's almost a full second. That's a huge difference. And so right now, we don't want to use our mean. The coach would want to use her median, and say, okay, well, Juanita's probably going to run around a 12-second 100-meter dash. And that's what he can expect from her based on all the times from all her races that she collected. So again, sometimes we want to use the mean, sometimes it's better to use the median when we're trying to find that center part of our data. Now here's the scary thing though, and this is why it's important to learn these things, because people can lie with statistics, right? So let's say instead of using the median, let's say Juanita told everybody she averaged a 13-second 100-meter dash. Well, they might think she was really slow, right? But really, that's all based on one bad race that she had to factor in. So it's important that you learn about these things, and that way when you're looking at statistics that are being presented to you, you can make intelligent, informed decisions and say, hey, I understand what they're saying there. Let's take a look at this you try problem, right? So it says Michael's trying to get a college scholarship for football. Below is a frequency chart, right? So basically just a count of all the touchdown passes that he threw for each game. We're going to find the mean, the median, and the mode. And then which of those would you want to use to describe the center of his data, right? So how many touchdown passes could you typically expect Michael to throw, all right? So in game 1, he threw 2, game 2 was 1, and so forth and so on. So you can use this right here. Go ahead and pause the video, try to solve it yourself, and you can just push play to check for your understanding. So here we have all of our data. I want to list it from least to greatest because that's going to help me find my mean, my median, and my mode. All right, we had 6 games here. And we have 1 touchdown pass all the way to 4 touchdown passes, right? So the range of this data would be 3, but that's not what this lesson's about. So if we want to find the mean, we're going to add them all up together. So we have 1, 3, 5, 7, 10, 14, and then we're going to do 14 divided by 6. And we're going to say he threw for an average of, and it's going to be repeating, but we'll truncate it after the hundreds, 2 and 33 hundredths touchdown passes, okay? So the mean is telling us, okay, you can expect Michael to throw a little over 2 touchdown passes a game. Let's take a look at the median. So if we cross these out one at a time, we're going to get left with 2 and 2. And when you add that together and divide by 2, the average of those would be 2. So our median says, okay, he's going to throw about 2 touchdown passes. And then our mode actually says the same thing, right? So our mode, there you could see the value 2 3 different times, so our mode was 2. So for this one, because there were no outliers, our mean, our median, and our mode are all about the same. So for this one, you could use any of them, but I would use the mean because there's no outliers. If he was going into his 7th game of the season, we could expect Michael to throw a little over 2 touchdown passes. Now, obviously, you can't throw half of a touchdown pass, but you can think to yourself, he's probably going to throw 2, maybe 3 touchdown passes based on all the data that he collected. So thank you for checking it out. Hopefully this is a little bit of a clarification, one, of what mean, median, and mode actually mean, but then even more than that, knowing that there are different situations where the mean would be best, there are different situations where the median would be best, and there are different situations when the mode would be best to use to help you find the center of that data. Check out the rest of our statistic units. We would love for you to join our InstructaBeats family by liking the video and subscribing. You can follow us on all our social media accounts. Again, thank you so much. InstructaBeats, out.